Hello everyone, welcome back to Full Stack Simplified. I am Prashun and today we are going to cover some of the most important JavaScript interview questions asked frequently in the interviews in the top product-based companies. We are going to start with polyfills for array functions today, and in the subsequent videos, I'll be covering more JavaScript interview topics. So without any further ado, let's quickly get started. So in the most of the JavaScript interviews, a very common question an interview asks is to write a polyfill for higher order functions like Array.map or filter or reduce and so on. So what exactly is a polyfill? So it is nothing but a piece of code that implements a relatively newer feature to run on legacy or old browsers, which does not support that particular feature natively. Since the evolution of JavaScript, there have been a lot of additional features introduced which we see across different ES releases. And although these new features are supported by modern browsers, there are many old browsers or even the older version of the newer browsers which do not support these natively. So in order to maintain backward compatibility and run these newer features across all the browsers, developers use polyfill. So today we are going to write polyfills for three array functions which are map, filter and reduce. So let us understand first how each of them work out of the box, and then we'll try to write these all from the scratch. So let us start with the array.map function first. So out of the box, map function iterates over a given array and returns a new modified array by executing the passed callback function as an argument. So this is a basic signature of array.map. So as you can see, we have an array on which this map function is called, and it accepts an argument, namely called the callback function, which again gives us three parameters: the item at ith index, the index itself, and an array which is in read-only mode. And now depending on this function which we pass, it iterates over the array and returns a modified one. So let us see an example how all these things work. So in here, as you can see, we have an array, the constant array with a value of 1 to 5. And then here we are running this map function over this array, and what we are doing inside this callback function is we are just multiplying each of the item, this 1, 2, 3, 4 and 5 by 2. And you can also see we are also logging the index and the array which we get in the callback function. If I go ahead and run this code, you can see that this is going to iterate 5 times, as we have 5 items in the array, and it is going to log all these as in the line 11, and now it is going to return new modified array in which every item is multiplied by 2. So as you can see, we have an original array with 1, 2, 3, 4 and 5, and now the modified array, each item is multiplied by 2. So this is basically how array.map function works. So now what we are going to do next is we are going to write a polyfill for this array.map function right from the scratch. So for this, in here I'm going to create a function called pmap, and as we used to pass a callback to the map function, here also we are going to accept a callback like this. And inside the function, if you remember, we always said that array.map returns a new array, right? So let us create a new array. So I'll say const res is equals to new empty array. And the next thing which we are going to do is we are going to iterate over the array which is getting passed, on which our pmap function will be called. And then we are going to use the callback function to modify and store the value in this new res array which we just now created. So I'm going to do a for loop here. So for let I equals to 0 till I less than the array on which our pmap function is getting called. So how to access this array? So we have this keyword in JavaScript. Now this keyword basically refers to a context over which a function is getting called. So in here, under this, we'll be getting the array over which the pmap function will be called. So I'm going to say this dot length because this is the array. So I'm going to say this dot length like this, and then I++. So in here, what we're going to do is I'm going to say res of ith index, and we're going to execute the callback which is getting passed. So I'm going to say callback like this, and always remember what we're passing, right? What the user gets when this callback function gets called. So I'm going to pass the this at ith index, that will give us the item, the index itself, and also don't remember we are passing an array which is in read-only mode, so I'll be passing the this like this. Now after we execute this callback, now whatever the condition will be passed by the user under this callback function, which will be storing it in the ith index of this result array, and also will be returning this result as it is. Now this is the basic polyfill function which we have created. Now we also need to attach this to the array.prototype. So there are a couple of ways doing this. One is simply to do array.prototype like this, and here we'll have our function like pmap, which will be equals to our function pmap like this. And now if I go ahead and just replace this map with pmap and execute it, we get the same result as we got with the map function, which is default in JavaScript. Now another way in which we can bind our polyfill to this array.prototype is by using object.define property. So we can do something like this: object.define property, and here we pass the object on which we want to bind a particular function. So here we pass the array.prototype, and the second argument is the property key, so we want to call this as pmap, and the third is an object with a value which points to our pmap function right here. Now if I go ahead and comment this first one and save this, this is going to run again without any error. So these are the two ways you can basically bind a function to its prototype. Now let us quickly move on to our second function, which is Array.filter. So first we are going to see how Array.filter works out of the box, and then we are going to write a polyfill for the same. So similar to Array.map, filter also iterates over an array and filter out item as per the given boolean condition passed as the callback body, and returns a new array with these all filtered items. So if you see a basic signature of filter function, here it accepts two arguments. The first one is the callback function, which is similar to the map function which we used to pass, and in each callback we get an item, the index, and an array which is in read-only mode. And here we have a second optional argument which is called context, or this arg, which you can pass to basically bind this filter function to some other scope. Now let us see a quick example and see how this array.filter thing works. So for this example, we are going to use the same array which we defined earlier, and we are going to call a filter function on this, and as we can see, we are logging the same thing, that is the index and the array which is in read-only form, and in here the only difference is the return condition. So in here what we want is, we want to return all the items in the array which is greater than 2. If I go ahead and run this code, you can see we iterate over the array 5 times, right? We get the index and the read-only array, and at the end in the modified array we get 3, 4, 5, as our condition was we want to get all the items which is greater than 2. So 1 and 2 is discarded because of this condition. So this is how filter works. So now next we are going to write the polyfill for this filter function. So for the polyfill of filter function, I'm going to create a function called pfilter, which is going to accept two parameters called callback and the context. Now in here, similar to the map function, I'm going to create an empty array called res, like this, and then I'm going to iterate over the passed array. So I'm going to use a similar for loop. So I'm going to say for let I equals to 0 to I less than this dot length, I mean the array dot length, like this, and then I plus plus. So talking of the second argument, the context here will be undefined by default, but if a user pass a this value for this context, we need to bind that scope to this particular function. So for that, what I'm going to do is I'm going to execute the callback function using the call method. I'm going to say callback dot call, like this, and in here I'm going to pass the context. So if there is a context, it is going to get bind with that. If not, it will be undefined by default. The next is this dot I, the item obviously. Next is the index, and then the last one is this itself, the array itself, which we pass as a read-only mode. Now as we already discussed, right, this callback execution will give us a boolean value, right, like we used to have here, item greater than 2. So we want to say, like, if this particular callback executes to be true, we are going to push the particular ith item to our res array. So I'm going to say res.push this dot I, right, like this. So if the callback function returns a true value, a truthy value, we are going to push that particular index item to our res array and then simply return the res, like this. Now if everything works fine, this should work and give us the similar output as the filter function was giving us. So let us replace this with pfilter, and also we need to bind it, right? So I'm going to follow a similar pattern using the object.define property, and in here I'm going to say pfilter, and obviously the value will be the pfilter, that is our function. Now if I go ahead and save this, you see we get exactly the same result. Now let us go and little bit change the condition, right? I'm going to say item is greater than equals to 2. Now we should also see 2 in the array. So this is how we write a polyfill for a filter function, and this is the expected value which we are getting in the console. So now let us move on to the last array function, that is reduce, and that is little bit typical to understand. So let's first see how reduce work out of the box, and then we'll write the polyfill for the same. So basically the reduce function executes an user supplied reducer, or the callback function which is getting passed as an argument on each element of the array, and in order passing in the return value from the calculation on the preceding element. Now the final result of this running reducer, the running callback function across all the elements of the array, is always a single value. So this will be more clear if we see a working example, and then you will be able to figure out what is this accumulator, the current item, and the initial value. So let us see a very simple example here. So in this example, what I'm trying to do is I'm trying to add up all the elements in our array. So in our array, that is the similar array, the 1, 2, 3, 4, and 5. So what I want to do is I want to add all those numbers and get a single value, that is the reduced value, right? So what I'm doing is I'm calling this reduce function over the array, and here we have the accumulator, right? And we also talked about the initial value. So initial value is an optional parameter, optional argument if you say. So if we pass an initial value, it takes it as whatever the passed value is, and if not, it defaults back to the first item of the array, right? So in our case, since we are not passing a second argument, so the initial value falls back to the first item in our array, that is the number 1, like this, right? So what we are doing is, in the first iteration in the accumulator, right, we have value 1. So what it is doing is it is adding 1 to the next item, that is 2, and storing it again back to the accumulator. In this way, this accumulator has always a summed value of the preceding element, and then we simply return this particular accumulated value to this reduced value. So if I go ahead and save this code, right, so this is going to run 4 times as we don't have an initial value, right? As I told you, initial value defaults to the first element of the array. Now it is going to run 4 times. So initially it was 1, then it got added to 2, so it now became 3. Then it again in the next iteration it got it add to 3 again, it became 6, and similarly we get a final value of 15, which is nothing but the summation of all these values. But let us see if we pass an initial value, right? Here we were not. Now if I go ahead and pass the initial value of 10, so now the accumulator will start with 10 as the first value, and then it is going to add 1, 2, 3, 4, 5. In return, we are going to see 25 as the summation of all the values. Now let us try to understand more and write polyfill for this particular reduce function. So for this, I'm going to create a function called p-reduce, which is going to have 2 arguments, the callback and the initial value. And inside this function, I'm going to have a variable called accumulator, which I'll be equating it to initial value. So if the initial value is passed, the accumulator will have its value, else it will be undefined, right? Now next I'm going to use again a for loop. So I'm going to say let I equals to 0 till I less than this dot length I plus plus, and inside this for loop I'm going to check if accumulator has a value. So if there is an initial value for the first iteration, it will be true. And now if there is no initial value, so for the first iteration accumulator will contain undefined, right? So we are going to check accumulator. So if accumulator is there, if there is a value in accumulator, I'm going to say accumulator is equals to the callback function. We're going to execute the callback function, pass the accumulator, the array's ith element, the index itself, and again as usual this, which is the read-only array. And now in the else case, if the accumulator doesn't have a value, so if the initial value was not passed, we are going to assign a value to it, like, and what is the assigned value? The first value in the first index, right? So I'm going to say if there is no value in accumulator, so accumulator will be equals to this dot I, like this. And in the end, what we're going to do is we are simply going to return the accumulator. So I'm going to say return accumulator like this. Now let us go ahead again and bind our reduce polyfill with the array.prototype like this. I'm going to say p-reduce, and here also we'll be pointing to p-reduce function like this, and I'm going to call our p-reduce. So I'm going to replace this, press save, and see we get exactly the same value. Let us also try with some initial value. This time I'm going to try with 20. We should get 35, and yes, we are getting a 35. So basically this is how you write a polyfill for any given array function. Now if you see this video and if you have reached to the end of this video, I'm pretty sure that you will be feeling very confident in your next JavaScript interview. So all the best, and if you really like this video, do hit the like button and also try subscribing to this channel. I'll be back with more videos on this particular playlist, so stay tuned and thanks for watching.